So hi class, and welcome back to my video tutorial about your lessons. So in this video I am going to discuss our lesson for week 11 and 12, which is the geometry of the circle. So probably you've already heard about circles in your previous levels. So probably you know already how to find the area of the circle. This area is equal to r squared times pi, and also the circumference. You know that. I know you know that already, how to find the circumference of a circle. You also know how to find the diameter, the radius. But in this lesson, this is not just all about the area and the circumference or any term that you probably know about circles. So in geometry, we can learn more about circles. So in this lesson, we'll look at how lines, the angles, and the arcs are related and in a circle. All right. So that should be our topic for this week, or this 2-week module, which is the week 11 and 12. So it's all about the geometry of circle. So in the pre-test part of this module, there's just a true or false question. So I know you can answer that because some of the items, or most of the items, were just basic concepts about circles, just basic facts about circles. So let's have the definition of terms. So what is a circle? In analytic geometry, or if you're familiar with the Cartesian plane, circle is a set of all points in a plane that are equidistant from a fixed point. And that fixed point is called the center of the circle. The fixed called is the center of the circle, and the constant distant is the radius. Right? Circle is named after its center. So in analytic geometry, so for example, you have a center and you have a fixed point, which is the center, and you have a straight line, which is a radius. It says that all points here, all points around from that fixed point, which is equidistant to each other, then that should be a circle. Okay? So for example, you have a nail here and this is a rope, and you're going to turn this rope in a circular pattern or a circular manner, then you can form a circle, and that's how the circle is formed. So next is chord. What is a chord? A chord of a circle is a line segment that has its endpoints on a circle. So if this is our circle, sorry for my drawing, then the endpoints of that line is in the circle. So we have endpoints here. For example, we have endpoint here, and we have also here. Then if you're going to connect that two endpoint, then that would be a chord. The diameter is just a chord that passes through the center of the circle. So a diameter is just a chord. It is a type of a chord, but the only difference is it passes through the center of our circle, and its length is twice as long as a radius. So the half of a diameter is equal to its radius. So let's proceed with our main topic, which is all about how the angles, the arcs, and the line are related to the circle. So the very first part of your module, the Explore, we have here a table where in the first column we have price, second column we have the color, the third column with a percent. Okay. And the radius of the circle is 0.5 meter. So we have here the picture. This is the picture of our table. So, the circumference of the circle is separated into arcs by the central angle. So when we say central angle, it is an angle that is formed in the center of our circle. For example, this is a central angle. This one, that is a central angle. So the circumference of the circle is separated into arcs by the central angle. This is also called the intercepted arc of the angle. So this arc here from D to E, this arc here from D to E, that is called an intercepted arc of the angle. And E to A, and the arc A to B. So that is called an intercepted arc of the angle. When the endpoints of the arc are also endpoints of a diameter, the arc is called the semicircle. So, the endpoints in our picture, the endpoints of the diameter is the point D and B. Then, the arc that is formed by that endpoints, here, this arc, the arc DAB, then this arc is a semicircle. So it is almost half it is half of the circle. So that is a semicircle. In the figure on the right, the central angles under intercepted arcs define each part of the circle called a sector. So this part here, kani, which is the central angles under intersected arc. So, muna yung central angle. This is the intercepted arc. Then, this part here, that part is a sector. A sector is, can you imagine a pizza? So, if you're going to get part of that pizza, circular pizza, then that part is a sector. Okay? If we are going to isolate this part, then it would be look like this. No. Sorry for my drawing. So that is a sector. Okay, let me do it again. Yan. So that is a sector. A sector is a part of the circle bounded by two radii and an arc. So this is the two radii. This is also a radii. Radii is a plural of radius. So, it's bounded by two radii, then it is a sector. Let's go with the table. So in the price, the recycle bag, this one, the blue part, the color blue, it is 25%. 25%. Yes, it is 25%. of the whole circle. Its central angle is defined by the angle ACB. Let me erase this. So this is the echo bag part. Let me change the color to let's switch. I think this is better. Okay, this one. This is the angle ACB. The angle ACB. The measure of the central angle, when you say central angle, it is the angle in the center. As you can see, this radii here, the two radii form a right angle, then that would be a right angle is equal to 90 degrees. And also, if you are going to base or to solve it, as we already know that a circle is equal to 360 degrees, then multiply it by 25% because it says that the ecobug part is 25% of the whole this whole picture. So multiply 0.25 times 360, and that would be 990 that would be 90 degrees, which is a right angle. So this angle here formed by the two radii, or the angle ACB, that would be a 90 degrees. Okay, how to find the area of this sector? So just get the ratio of the area of the sector, the ratio of the central angle to the angle that is formed in a circle, which is 360 degrees, times pi times r squared. Since our r is equal to 0.5, so it is equal to 1/2. 0.5 is also equal to 1/2, or so it will be 90 over 360 degrees equal to 1/4 times 1/4. Since 1/2 to the power of 2 is 1/4 pi, then the answer is 1 over 16 pi. So this area here is equal to 1 over 16 pi. Okay, that area is 1 over 16 pi. And the intercepted arc, this arc, this arc here, that is our arc AB. Or we can read it the other way, or arc AB or arc BA. Anyway, you can in any way how you read it, it is correct. So it's either arc AB or arc BA. Okay, so that's how we solve for the table. Another one, the AA battery. So it is the yellow one. So since it's since it is 10% of the whole, so angle E, so this is the angle ECA. So what is the measure of the central angle? So just multiply 10% of 360 degrees, or 0.10 times 360 degrees, then that would be 36 degrees. How to get the area of that sector? So just do the same process as we did a while ago. Just get the ratio, or 36 degrees over 360 degrees, that would be 110 times the area of the whole circle, which is pi over 4, or 1/4 pi, then that would be pi over 40. So the area of this battery portion is pi over 40. And the arc intercepted by the central angle angle ECA is arc EA or arc AE. You can read it the other way around. Alright? So I let you solve for this. I let you discover for the remaining two rows here. I'll let you study this. So we just solve it the same procedure as we solved the first two. Okay. Since a semicircle is half of a complete revolution or a circumference, its measure is 1/2 360 degrees. We all know that a circle makes a 360 degrees revolution, or a circle is composed of 360 degrees revolution. Then a semicircle is equal to 180 degrees because it is 1/2 of a circle. Right? So just multiply 1/2 times 360 degrees, and that would be 180 degrees. Alright, so there are ways to classify angles according to their measures. An arc may be classified as minor, major or semicircle. An arc that is not a semicircle is either a major or a minor arc. Okay? We have three classifications of an arc. First is the minor, second is the major, the third is the semicircle. So what are the difference of these classifications of arcs? So let's go first with the minor arc. So given that circle W, as you can see in our picture on the right side, with points X and Z on the circle, this is the point XZ, the union of XZ and all the points on that circle that are interior of the angle XWZ is called a minor arc. So this arc here formed by points XZ is called a minor arc. Minor arc, right? Its measure is equal to the measure of its central angle. So always remember, the measure of a central angle is equal to the measure of its intercepted arc. So let's go with the major arc. Given that circle W with points XZ on the circle, the union of XZ and all the points on the circle that are exterior of ZXWZ is called a major arc. It measures is equal to the difference between the measure of its related minor arc. Minor arc of the same endpoints as the major arc and 360 degrees. So this XYZ, XYZ, the arc XYZ is a major arc, meaning mas dako siya nga arc. So arc XZ is a minor, arc XYZ is a major arc. Then how can we find for the measure of this major arc? Just subtract 360 minus the measure of our minor arc, which is 100 degrees, then it is equal to 360 degrees. So XZ and arc XZ is a minor arc and arc XYZ is a major arc. Another difference is a minor arc is only composed of 2 letters, while the major arc is composed of 3 or 4 letters, or 3 or more letters. Notice that the names of the 3 types of arcs suggest their measures relative to 180 degrees. This means that a minor arc has a measure that is less than that semicircle. So, as you can see in our table, a minor arc, if it is less than, if an arc has a measure that is less than 180 degrees or less than a semicircle, then that would be a minor arc. If it is equal 180 degrees, then that would be a semicircle. If it is greater than 180 degrees and greater than a semicircle, then that would be a major. That would be a major arc. Right? A major. Just take note. A major arc has a measure that is more than of that a semicircle. If it is more than a semicircle or sobra sa semicircle, then that would be a major arc. If semicircle, it is half the circle. If minor arc, it is less than a semicircle. And also, a semicircle is only composed of 2 letters, and a minor arc is only composed of 2 letters, and a major arc is composed of 3 letters. Okay? Or, since letters denotes or symbolize points, then we can also say that a minor arc requires 2 points, while a major arc requires 3 different points, or requires the use of 3 points. Okay, let's go with the example. Give the measure of each arc and classify its type. Let's go first with the arc AB. Where's arc AB? Here. This is arc AB. So what is the measure of arc AB? As you can see, arc AB is an intercepted arc of a central angle ACB, which is 90 degrees, or which is a right angle, and it is also 90 degrees. Therefore, arc AB is 90 degrees, and it is a minor arc because it is less than 180 degrees. That is 90 degrees. Next, let's have the arc DE. Where's the arc DE? This is the arc DE. The arc DE is equal to its central angle ECD, which is 54 degrees. Therefore, the arc DE is also 54 degrees. And since it is less than 180 degrees, or it is less than a semicircle, then it is a minor arc. Another one, the last one is the arc EA. How can we find for the central angle of the arc EA? Since this arc here that can be formed by the endpoint DA is 90 degrees, so we can just subtract 90 and 54 to find arc EA. So 90 degrees minus 54 degrees, that would be 36 degrees. So arc EA, the central angle ECA is 36 degrees, therefore arc EA is equal to 36 degrees. Since it is also less than a semicircle, then it is a minor arc. Right? Right, so the next video I'm going to discuss you all about the inscribed angles. So for now, that would be our that would be the content of my video, or my video tutorial. Is just introduction about the geometry of the circle. My next video I'm going to discuss the inscribed angles, right? So I hope you can answer your activity, and I hope you got a high score. So that's all for now, and thank you and bye bye.